Hey there. So you're really diving deep into the history and philosophy of science, huh? Specifically, that nature of science section. I know it can be a real brain twister.
Oh, it's definitely a tricky one, but don't worry, we're here to help guide you through it.
Oh, that's great to hear. And you know what? The material you sent over, it actually has some really cool definitions and examples. I think those will really help us break down this whole nature of science thing.
Yeah, absolutely. We'll make sure you walk away feeling confident and ready to tackle those exam questions.
Perfect. Now, from what I've read, it seems like defining science is a little more complicated than just saying it's knowledge about the world,
Right.
right? Like, how should we be thinking about this for the exam?
Yeah, you're right. It's definitely more nuanced than that. Think of it this way. To really nail this section, you need to understand how science is defined, the different branches of science, the aims of science, and also how it's different from non-science disciplines.
Okay, that gives us a good roadmap. So let's start with definitions. The source material mentions something called the three-legged stool of science. What's that all about?
Ah, yes, that's a great way to visualize it. Each leg represents a core aspect of science. Science as a body of knowledge, science as a method, and science as an institution.
Okay, I'm intrigued. Let's break down each leg, starting with science as a body of knowledge. I kind of thought that was the whole story, but it sounds like there's more to it.
You got it. It's not just about knowing a bunch of facts. While this leg covers the classic sciences like biology, chemistry, and physics, what's really important to grasp is what makes scientific knowledge different from other types of knowledge, like religious knowledge, for example.
Right, that makes sense. So what makes scientific knowledge unique?
It all comes down to both what science studies and the method it uses to gain that knowledge. Science is focused specifically on the natural world, and it relies on systematic observation and experimentation. And that actually leads us perfectly to the second leg of the stool, science as a method.
Oh, okay. The scientific method. I remember learning about that in school. Does this apply to all types of science, though?
It does, but it can look different depending on the branch of science. And this is where understanding the difference between empirical and formal sciences becomes really important. This distinction is likely to pop up on your exam.
Formal sciences. That rings a bell. Isn't it like math? The source material mentions something about the Bodamias rule bracket, orders, division, and multiplication, addition, and subtraction. I used to get tripped up on that one.
Yes, math and logic are classic examples of formal sciences. They rely on deductive reasoning and operate within strict systems of rules, like Bodamias. They arrive at knowledge through logical proof and reasoning. Empirical sciences, on the other hand, rely on observations and experiments to test their hypotheses.
So formal sciences are about working within abstract systems and rules, while empirical sciences are more about getting your hands dirty collecting data from the real world. Did I get that right?
Exactly. Picture a biologist studying animal behavior out in the wild. They're observing, taking notes, collecting data, and drawing conclusions based on real-world interactions. That's what empirical science is all about.
Okay, two legs down, one to go. What about this science as an institution thing? That one sounds a bit more abstract to me.
It does, but it's actually highlighting the collaborative and self-correcting nature of science. Think of it as a massive global team effort with millions of scientists around the world all contributing to this shared body of knowledge. They're building on each other's work, constantly checking and refining our understanding of how the universe works.
Wow, it's like this giant network of knowledge builders. I'd never really thought of it that way before.
Yeah, it's a pretty amazing system, and it's a key point to remember for your exam. Any questions about these definitions before we move on to the different branches of science?
No, I think you explained that really well. That three-legged stool analogy is going to be super helpful for remembering all the different facets of science. So are we ready to explore those branches now?
Absolutely. Let's climb that tree of scientific knowledge. So we've got the definitions down, and now it's time to, well, branch out, literally, into the different types of science.
Uh-huh. I'm ready to climb that tree you were talking about.
Hmm.
And from the source material, I remember there were two main ways to group these branches of science.
That's right. We can group them by the method they use, which is that formal versus empirical thing we just talked about, or by their subject matter.
Right. Formal sciences are all about abstract systems, like math with its Bodhi-MAS rule, and empirical sciences are about observing and experimenting in the real world. What about the subject matter groups?
Well, that's where we get into natural versus social sciences. Natural sciences are focused on the natural world, things like biology, chemistry, physics, the classic sciences. Social sciences study human behavior and society fields like psychology, sociology, and economics.
So natural sciences are about the laws that govern the universe, and social sciences try to make sense of how humans interact with each other and the world around them. Makes you wonder if there's any overlap between them, though.
That's a great question, and it brings up a really important point. These branches aren't always totally separate. Take biochemistry, for instance. It kind of bridges biology and chemistry by looking at the chemical processes happening inside living organisms.
So it's like a Venn diagram where the circles overlap. I remember those from my science textbooks. Does that blurring of lines happen a lot?
More and more these days, actually, as we learn more and connect different fields. You even have things like environmental science, which pulls in knowledge from a bunch of different natural and social sciences to understand complex issues.
Makes sense. Try to keep everything in rigid categories would probably limit our understanding in the long run. So for the exam, should I be focusing on these overlaps, or is it enough to know the basic categories?
Knowing both is key. The basic distinctions, formal versus empirical, natural versus social, those are your foundation. But if you can point out the overlaps, it shows you have a deeper understanding of how scientific disciplines all work together and grow.
Got it. Highlighting those connections in my notes. Now, switching gears a bit. I'm curious about the aims of science. Why do people even bother doing science in the first place? I bet that'll be on the exam.
Definitely a fundamental question. At the core of it all, science comes from human curiosity, this innate desire to understand the world around us. We observe, we question, and we search for explanations for the things we see.
So it's all about satisfying that thirst for knowledge, huh?
It's definitely a part of it, but there's more to it than that. Science isn't just passively observing, it's also about actively shaping our understanding and, in turn, shaping the world itself. Think about all the technology we have today, like smartphones and life-saving medicines. They all came about because of scientific advancements.
That's a great point. So science is both theoretical, offering explanations, and practical, giving us the tools to solve problems and improve our lives.
Exactly. That dual nature, the pursuit of knowledge for understanding and for practical application, is what makes science so powerful and relevant to our lives.
Okay, another key takeaway. Understanding both the theoretical and practical aims of science will definitely help me write a well-rounded answer on the exam. There's one part I'm still a little fuzzy on, though telling the difference between science and non-science disciplines. How can you really tell them apart?
Ah, yes, the age-old question. This is where things get a little philosophical.
It always makes my head spin.
Well, think back to what we said about the scientific method. Science depends on observation, experimentation, and logical reasoning to gain knowledge. It's all about explaining and predicting things in the natural world. Non-science disciplines, on the other hand, might rely on other ways of knowing, like faith, intuition, or personal experience.
So religion is about the supernatural and relies a lot on faith, while science sticks to the natural world and wants empirical evidence. Would you say that's a fair distinction?
Yeah, that's a good starting point. And think about it this way. Art explores things like beauty and aesthetics, while science aims to uncover the fundamental principles that govern the universe. It's about seeking objective truth through methods that can be verified.
Okay, I think I'm seeing the difference more clearly now. But the source material did mention that it's not always so black and white. It even said that common sense has a touch of scientific thinking.
Now, that's an interesting point. While common sense isn't systematic or rigorous like scientific inquiry, it can sometimes involve those basic observations and inferences about the world. Take traditional farming, for example. It developed over generations based on trial and error, observing the weather, and understanding plant cycles.
So even though it's not formal science, there's a practical empirical basis to it. Is that why the lines can get blurry sometimes?
Exactly. Recognizing those nuances is really important for understanding how complex this whole issue of distinguishing science from non-science can be. It's not always a simple yes or no answer.
Okay, got it. So being aware of those gray areas is important for the exam, right? It shows a deeper understanding of the nature of science and its relationship to other ways of knowing.
Absolutely. It demonstrates critical thinking and that you understand the nuances.
Okay, feeling much more confident about that section now. Anything else I should really remember about this whole science versus non-science thing?
Oh, yes. One crucial point. Even though science aims for objectivity, the scientists doing the science are still human, right? They have their own biases, values, and limitations.
Oh, right. We talked about how observation can be subjective.
Exactly. And it's super important to be aware of those human elements because they can influence the direction and interpretation of scientific research.
So it's not enough to just accept scientific findings at face value. We need to think critically, consider the context of the research and be aware of potential biases.
Exactly. Being scientifically literate means being able to evaluate scientific claims, weigh the evidence, and make informed decisions based on the best information available.
Wow, that's a powerful point. I'll definitely keep that in mind as I keep studying.
Excellent. Okay, so we've covered definitions, branches, aims, and the whole demarcation problem. Ready to dive into the heart of the scientific process, the scientific method.
Bring it on. I'm ready to unravel the mysteries of how science really works. Okay, so we're back, and I'm ready to tackle this scientific method thing. It's always seemed kind of mysterious to me, to be honest.
Yeah, I get that. It can seem a bit intimidating, but at its heart, it's just a systematic way of exploring the world and building knowledge.
Okay, that makes sense. So break it down for me. What are the key steps involved?
Well, it all starts with observation. Scientists, they're naturally curious people. They see patterns, they notice things, and they start asking questions about the world around them.
Like a biologist noticing that some birds have brighter feathers than others, or an astronomer looking at how the planets move.
Exactly. Those observations then lead to the next step, which is formulating a hypothesis. A hypothesis is basically an educated guess, a possible explanation for what they've observed.
So the biologist might guess that those brighter feathers help the birds attract mates. Or the astronomer comes up with a theory about how gravity affects the planet's orbits.
Precisely. And to test those hypotheses, scientists design experiments. They carefully control different factors, collect data, and then analyze the results to see if they support their initial guess.
So it's all about putting those educated guesses to the test, letting the evidence speak for itself.
Exactly. And that's where analysis comes in. Scientists, they really dig into the data they've collected, looking for patterns, trends, anything that's statistically significant.
So it's not just about collecting data, it's about making sense of it all and drawing conclusions that actually mean something.
Right. And if the data supports the hypothesis, it can lead to the development of a scientific theory.
Hold on a second.
Mm-hmm.
Isn't a theory just a guess? Like, I have a theory about why my toast always lands butter side down.
Uh-huh. Well, that's a common misconception. In science, a theory is a well-supported explanation of something in the natural world that has been tested over and over again, and the evidence keeps backing it up.
Oh, okay. So it's not just a random thought. It's a powerful idea that's supported by lots of evidence.
Exactly. Think of things like the theory of evolution or the theory of gravity. These aren't just random ideas, they're the cornerstones of how we understand the universe.
That makes a lot more sense now. I'm starting to see how the scientific method is like a cycle of observation, hypothesis, experiment, analysis, and then maybe a theory comes out of it.
You got it. It's a dynamic process that's always refining our understanding of the world.
Okay, so we've covered the steps, but is it foolproof? I mean, we talked earlier about how science has its limitations, right?
That's a really important point. No scientific method is perfect. There's always the possibility of human error, limits to our technology, and of course the natural world is incredibly complex.
So even with all the careful testing and analysis, there's always a chance that we'll discover something new or have to change our understanding.
Absolutely. Science is constantly evolving. What we think is scientific knowledge today might be modified or even completely overturned tomorrow as new evidence comes to light.
Wow, that's both exciting and kind of humbling. It means there's always more to learn and discover.
That's the beauty of it. Science is this never-ending quest for knowledge, driven by curiosity, a healthy dose of skepticism, and a willingness to challenge what we think we know.
I have to say, this deep dive has given me a whole new appreciation for the scientific process. It's not just about memorizing facts, it's about understanding the methods behind the discoveries.
I'm glad to hear that. And remember, the scientific method isn't just something that happens in labs and research institutions. It's a way of thinking that you can apply to everyday life.
Well, that's interesting. So by being observant, asking questions, and looking for evidence, we can all think a bit more scientifically.
Exactly. And that's a super valuable skill to have in a world that's overflowing with information and claims. It allows you to look at evidence critically, make informed decisions, and navigate the complexities of the world around us.
Well said. I think we've covered a lot of ground today. We've defined science, explored its different branches, talked about its aims and methods, and even touched on some of its limitations.
I think we've definitely given our listeners the tools they need to ace that exam section on the nature of science.
I feel so much more confident now. And more importantly, I think I really understand what science is and how it shapes our understanding of the world.
That's what we strive for here at the Deep Dive, to go beyond just providing information and really help people understand.
And on that note, we'll wrap up this episode of The Deep Dive. Thanks for joining us on this journey of scientific exploration.
Keep those questions coming, keep exploring, and keep diving deep into the wonders of the natural world.